Okay, so ninth video, crazy videos. All right, so let's do this one. And in order to do this one, you have fractions up here that you need to subtract, and then you have a division bar and then another fraction. So let's take one step at a time. Let's just cover up and ignore the denominator for now. Let's just pretend that this is the only problem we need to deal with. So if you have two fractions that you're subtracting, and obviously your denominators are not exactly the same, you're going to have to get a common denominator. So let's move this to the side. What is the common denominator going to be?
X, Y.
It's going to be both of these put together with multiplication. X minus y times x plus y. All right? So we're not even going to multiply them. We're just going to write them together. Okay, so there's a common denominator. So we have to ask ourselves, what do we do to this x minus y to get an x minus y times x plus y? Obviously, we're going to multiply both bottom and top by x plus y. So when we multiply the top, 3 times x, we get 3x. When we multiply 3 times y, we get 3y plus 3y. And then we have to ask ourselves, what do we do to the second fraction, or the second fraction to get that new LCD? Well, you have an x plus y. Right here you have an x plus y times x minus y. So obviously you need to multiply both top and bottom by x minus y. So there it is. When we multiply the top, 1 times x, 1 times minus y, that will be x minus y. Now keep in mind that there is this minus sign between them. So there's a minus sign between the two fractions, which means that if you have a binomial over here, which you do, you have to actually distribute that minus sign when you combine the numerators. So we know that our answer is going to be over the common denominator, x plus y, x minus y. But what we need to do now is just combine like terms. So I have 3x, and that's going to be take away x. What's 3x take away x? That's 2x. And then we have 3y, and we have this minus y actually becomes a plus y because of the minus. It's kind of like saying 3y minus minus y, or you could distribute it and make it plus. So we really have 3y plus y. That'll become a positive 4y. So plus 4y is what you have up on top. Ladies and gentlemen, that is our answer only for the numerator. So now we have this denominator that we need to deal with. In other words, we have this answer that we got for the top part, and now it's going to be divided by 5 over x minus y. Okay? So we need to understand what we have here. We have an answer divided by 5 over x minus y. Now that looks confusing because it's a complex rational. You have a fraction divided by a fraction. How about we write it horizontally and it'll look a little bit nicer. I'm going to write the 2x plus 4y over x plus y, x minus y divided by this, but horizontally. So this definitely looks a little bit nicer than the above, right? When it's horizontally. And now we know that when you divide by a fraction, you need to multiply it by the reciprocal. So you need to flip it. So the first thing to do is rewrite that first fraction. Change the division to multiplication, but flip the second fraction. So it's going to be an x minus y up on top and a 5 on the bottom. And now we could start canceling things out. But before canceling things out, is there anything that could be factored? And the answer is yes. The 2x plus 4y, you could factor out a 2 and see if that makes a difference. If we pull out a 2, we're going to have an x plus 2y left over, and it won't make a difference. But anyways, we rewrote it by factoring it. That's fine. Let's now cancel out anything possible. We have an x minus y up on top and an x minus y on the bottom. That cancels out. And then nothing else cancels. So your final answer is what's left over. What do we have left up on top? We have a 2 parenthesis x plus 2y. And on the bottom, we have a 5 parenthesis x plus y. That is your final answer for that one. You could practice with the other one that we have there. Number 31, they want us to find the asymptotes. Okay, those are the lines that the graphs infinitely approach, and also state the domain range of each function. So let's first do a little bit of notes right here. For asymptotes, your vertical asymptote will simply be x, because any vertical line is x equals, right? X equals 3 is a vertical line, x equals 2 is a vertical line. But when you're talking about these functions in particular, the vertical asymptote will be x equals your h value, whatever your h value is. And remember, your h is always with x, and you always think opposite of what you see. Now for the horizontal asymptote, that's going to be y, because y equals gives you any horizontal line. Y equals your k value. So it's that simple. These are your notes that you need to know. The vertical asymptote is x equals your h value, and that makes total sense because x is always with h. Horizontal asymptote is y equals your k value. Okay, so let's take a look at. So looking at part C, you guys could practice with the other ones, but part C, you want the vertical asymptote. That will be x equals your h value. So what is our h value here? It's the value you see here with x inside parentheses, in this case in the denominator, but you think opposite, so that will be 1. Okay, so that's your vertical asymptote. Okay, how about your horizontal asymptote? We said the horizontal asymptote is y equals the k value, and the k value is the one that's being added or subtracted at the very end, and you take that for what it is. So -3 is your horizontal asymptote. Okay, so that's one thing that you need to state. It'll be on your multiple choice answers. It's going to say x equals 1, that's one answer. Y equals -3, that's another answer for the vertical and the horizontal asymptotes. And then it goes on to domain and range. So I think the notation that they'll give is D for domain. It's going to be x, comma, and that really means x equals all real numbers. So let me just let me actually rewrite it as x equals all real numbers. However, you cannot have a certain x value, but x cannot be the asymptote 1. So that's your domain, all real numbers, but your x value can't be the asymptote 1, so x cannot be 1. And for your range are your y values. So you say y is all real numbers, but then again, your y cannot be the asymptote of the horizontal one, which is -3. So there's your domain over here, your range over here, and your vertical and horizontal asymptotes, and that's all they're asking for. So I will let you practice with the other ones. Let's move on to number 32. Let's solve this equation or an inequality. It also says check your solution. Make sure you don't have any extraneous answers. So right here on number 32, we have an equation. It has fractions involved. So you want to get rid of the fractions. You're going to have to multiply everything by the denominator, the fraction you want to get rid of. So what I'm going to do is multiply everything by b minus 1. So I wrote the binomial b minus 1 times every single term on that equation. Of course, on some of you have to distribute, like b times b, that's going to be b squared. B times -1, that's going to be -b. And then over here, the b minus 1 cancels with the b minus 1. That was the whole purpose of multiplying everything by b minus 1. So we have plus whatever's left over, 2b. Then you bring down your equal sign. And right here, you have to distribute 1 times b, that is b. 1 times -1, that's -1. And of course, over here, the b minus 1 on the bottom with the b minus 1 on top also cancels out. Now, right here, it's a little tricky because you have a minus sign, and it's a binomial b minus 3. So that minus sign needs to be distributed to the b and to the minus 3, giving you a minus b and a positive 3. Please don't make a mistake on the test right there. Distribute the minus sign. Now after that, since you recognize it's a quadratic, you're going to try to set it equal to 0 and factor, but if you can't factor, you could always fall back on the quadratic formula. However, there is things that we could combine and simplify before setting it equal to 0. For example, -b plus 2b, that's going to be positive 1b. So I could combine those two, rewrite the b squared plus 1b, bring down the equal sign, and over here I could combine b minus b, that cancels out, and the 1 plus 3, that's going to be a 2. So that's my new simplified equation. Whoa. So now we have this quadratic equation. Let's set it equal to 0 by subtracting 2 there and subtracting 2 here. So we're going to rewrite it. It's going to be b squared plus 1b minus 2 equals 0. And now we could actually factor, split, and solve. So you put b and b, and then you think, what times what is negative 2 that if you combine together is positive 1? Well, that'll be a positive 2 times a negative 1. So that's the correct factored form. And then after that, you split it and solve. So if you have b plus 2 equals 0 and b minus 1 equals 0, you're going to get an answer of b equals negative 2 and b equals 1. So our two answers are b equals negative 2 and b equals 1. Now the question is, are those acceptable answers? You need to take the time and take that negative 2 and make sure that it doesn't give you 0 in the denominator. Negative 2 minus 1 is not 0. Over here, negative 2 minus 1 is not 0. So negative 2 works just fine. B equals negative 2. That's one answer. However, when you try b equals 1, when you plug in 1 right there, 1 take away 1 is 0, which makes it undefined, which means that that cannot be an answer. I want to cross it out. That's what I call an extraneous solution. The only answer is b equals negative 2. And of course, you guys could practice with 32b. Let's move on to 33. I have an inequality. I have fractions. I want to get rid of these fractions by multiplying everything by the denominator of the fraction that I want to get rid of. Now, I could get rid of all fractions at once by multiplying everything by the LCD. What would the LCD be right here? 15p, right? So if I put a 15p, and a 15p, multiply everything by 15p, it'll cancel out all fractions at once. For example, this p and this p cancel out. I'll have 15 times 4, which is 60. And then the p and the p cancel out, and the 3 and the 15 cancel out. You have a 5 left over, and 5 times 1 is 5. And then over here on the other side, the 5 and the 15 cancel. You'll have a 3 left over, actually a 3p left over. 1 times 3p is 3p. So what we really have is 60 plus 5, that's 65, is less than 3p. So if I want to solve this thing, I need to divide both sides by 3. That'll cancel out. And I'll have p is greater than 65 divided by 3. 21.6, and it continues. So you know what, I'm just going to leave it like a fraction. I'm pretty sure on the test it actually works out nice. And I'm going to rewrite it. Instead of 65 over 3 on this side, I'm going to write p on this side, 65 over 3 on that side, with the greater than symbol, because it has to open up to the p the way it did up here. So there's my answer. In addition to that answer, you need to go back and set your denominators equal to 0, because that would mess it up. Okay, so if I go back to this denominator p and set it equal to 0, the p value of 0 would mess it up. And even 3p, if I set that equal to 0 and solve it, p still equals 0, and that would mess it up. So what we need to do for this final step here is to make a number line, put your 0 value, put your 65 over 3, which is 21 point something, and test your values. So if you put a negative number in there, like let's say negative 1, if you plugged in negative 1, would it work? If you plug in a negative 1 right here, it'll be 4 over negative 1. That's negative 4. 3 times negative 1, that's negative 1/3. Negative 4 plus negative 1/3, that's going to be a negative number and definitely will be less than a positive 1/5. So this way does work so far. Let's test the value that's in between 0 and 65. Let's use positive 1. So let's test positive 1 right there. When you plug in 1 right there, it's 4 over 1, that's just 4. 4 plus 1 over 3, because 3 times 1 is 3. 4 plus 1/3 is 4 1/3, and that's not less than 1/5. So the inside value does not work. And how about the outside value in the other area over here, which we said this was 21 point something, try a value greater, which it does work, which makes it a compound inequality, but I ran out of time.